Hey guys, welcome back to AlgoYogi. We have two more problems in the two-pointer series. Next one is sentence similarity third problem. Let's go to LeetCode. So it says you are given two strings, basically sentence 1 and sentence 2, each representing a sentence composed of words. A sentence is a list of words, of course we know that are separated by a single space with no leading or trailing spaces. All right. So each word consists of only uppercase or lowercase English characters. Two sentences S1 and S2 are considered similar if it is possible to insert an arbitrary sentence, possibly empty, inside one of these sentences such that two sentences become equal. I'll also note that the inserted sentence must be separated with existing words by spaces. Okay, all right. For example, they have given us, to make things clear, S1, sentence 1 is hello Jane, and sentence 2 is hello, my name is Jane. So if you see over here, sentence 1 is a smaller sentence. So now sentence 1 can be converted into sentence 2 by inserting these group of words separated by spaces. Okay, so hello Jane, and inside that sentence S1 we have inserted my name, and that too with a space. And when you're inserting inside S1, then also like it has to be with the spaces. Then this can be if we have inserted my name into hello Jane, this becomes sentence 2. All right, so that is basically in this case will return true, because these two sentences S1 and S2, doesn't matter which one you're converting, although in this case, because S1 is smaller, you're converting S1 to S2 because S2 is greater by inserting something in the middle. All right, and another example, S1, so frog cool, S2 is frogs are cool. They are not similar because, although remember this S is not present in this frog, so this part is basically being inserted into S1 to make it same. But the thing is there is no space over here. There should have been a space between frog and S, and in the beginning, even then it wouldn't become equal, because actually it would become equal if there was a space here, because now we are inserting S and R into here with a space. Right now we can not make them equal, right? Because this was a condition over here, this was a condition over here. Note that the inserted sentence must be separated from existing words by spaces. Okay, all right, so let's we can try to understand them on a notepad, the examples again. So in this example you can see S1 is my name is Tom. In this one this is basically greater, and remember, like there are no spaces here, like don't think this is a space. Okay, so S1 is my name is Tom, S2 is my Tom. Now since S2 is smaller, we would rather try to make S2 S1, basically by inserting this group of words, another sentences separated by spaces. So we see that we basically insert this part into here, and this will make this S1, and that is perfectly valid given the conditions in the problem statement to us. So now if we are inserting name is in between my Tom, that becomes my name is Tom. All right, so how can we actually check it? So what if I have basically two pointers. One is basically pointing to the beginning of my S2, I'm gonna call it L1 left 1, and then I have R1, which is basically pointing to the end of my sentence 2. Also remember, like, I think what would be easier is like if we switch, basically let's always keep sentence 1 as the smaller sentence that we are trying to make into a bigger sentence, which is S2. Right, we are converting S1, always converting S1 to S2, because right now they could be any sentence could be converted into another one, but it would be easier for us if we always trying to convert S1 to S2. Okay, so we switch their values. We will do that if length of S2 is smaller, then we switch both of them. So in this case also we could do that. So I'm gonna do this, I'm gonna switch them. So I'm gonna switch them. So I'll make this one S1, sorry, S2, and this one S1. And then I'm also gonna have my other 2 pointers pointing to S2, and that will be L2 and R2. So what will happen now is, what I want to do is I want to see the occurrences of these words, all of these words here, such that I am basically starting my pointers at the end and I keep them moving closer, the L2 and R2, I keep them moving closer so that I'm able to see all of these words, starting this one over here and starting L1 over here, and whenever I'm seeing they become equal, then I keep basically incrementing. So keep them incrementing, keep incrementing and keep decrementing R1, keep incrementing L1, and same as with L2 and R2, as long as you see so L1, and I'm gonna say like L1 equals to L2 and R2 equals to R1, and we're gonna keep doing it. Basically we're gonna do it in two passes. First one for basically we can choose L2 and L1, so we keep moving forward, and then in the second pass we do for the back. And the reason we are seeing the reason we are doing is because at the end of the day what we want to see is either this particular string that we are seeing here, my tome, what might happen is either this will occur either in the beginning, which is like a prefix of S2, or it might be in the end. Remember, it could have been in the end also, and still we would basically be able to convert it. Inserting something in the middle doesn't really mean like you are really inserting in the middle only. You will see like another. I'll show you another example. I think that's the example 3, I guess. Let's have a look. Right now only. So let me switch. Okay. So I'm not able to see it, but let me. Okay. Yes. So in this sentence 1 is eating right now, and sentence 2 is eating. Okay, so this is the smaller sentence, and remember we'll just switch them. So this will become a sentence 1. Sentence 1 is what we are trying to convert to sentence 2. So this is sentence 2, eating right now. So see, the answer should be true because what I have done here is I have inserted this part next to eating, right? So what I was seeing through pointers is I want to see all the words in my sentence 1. Remember, I keep saying it sentence 1 because I'm trying to I have flipped their values because I want to have some consistency for me, that I'm always trying to convert a smaller sentence into the bigger sentences, and I'm not really converting it. I'm just seeing that this has occurred either in the beginning or the end, so that this is being inserted, either in the end, beginning, or somewhere in the middle. Those are the three scenarios that can happen. And to check that, what we are doing is we'll have our L1 pointer and R1 pointer, and L2 pointer and R2 pointers. And what I'm seeing is I keep moving these pointers closer, given in, like, I'll do that in two passes. First is for the L pointers, left pointers, and another for the right pointers. So if I want to see, have I seen this from the beginning anywhere? Maybe this was not equal, even if this was equal, we will keep going, we will keep going. So there might happen that, like, this eating, basically this occurred later as well, right? And this was, we weren't considering it, so this can occur either in the beginning or in the end or somewhere in the middle. So this is what I'm talking about. This can occur anywhere. All right, so I guess let's go back to, so now we haven't, also this second example is also pretty interesting. So sentence 1 is smaller, perfect case for us, so we want to convert it to sentence 2. We can't do that. Why? Because you cannot insert, so we have to insert group of words somewhere here, and they have to be contiguous. So right now it's like you inserting this over here, you're inserting this in the end. That's not possible. That's simply not possible, because right now we were supposed to insert this another part of sentence separated by spaces. Right now it's not separated by spaces, separated by this another word only, which is part of sentence 1. So you can't do that. All right, so this explains that we can only insert either, like, insert something in the beginning or something in the end or something middle of in this scenario what must have been the case. So this is the reason that I'm saying we can only see this part either in the beginning or in the end or somewhere in the middle. This is what we were trying to see, but not in the middle of the this sentence. Okay. All right, so we were right here. This is a really complicated problem, honestly. Like, my head is spinning even right now. Like, just if you think that it's not a great explanation, I would rather sit down and try it your own. I think that's the best way. It's one of the crazy problems, I guess. Well, anyway, I'm just gonna go. I'm gonna do it and just move on, because one problem just doesn't really, decide. All right, so this we have gone over, and once, so how do we return basically our answer? So if we see that our L1 basically becomes greater than our R1, that means we have seen all of these words inside my my sentence 2, because that's where I was trying to observe. That's where I was trying to observe the occurrences of my sentences 1 words inside here. Okay, so my occurred over here. So these could have been either in the beginning or in the end or somewhere, like, anywhere, like in the end, and there must have been some words right here or here. All right, and if my L1 becomes basically greater than or equal to R2, that means I have seen all the words and I can return this. And I think it will be not equal to, just greater. So let's write down the solution. Would be simple, I guess. I think solution would be just direct conversion of our logic, which would be what I want to have is first yes, let's have L1 and let's have L2, both pointing to 0 and 0. Then I have R1 and R2. So now they're pointing to, R1 is pointing to length of sentence 1. Okay, and R2 is pointing to Same thing, but sentence 2. One thing is that I wanna we have decided this, like if len s1, if len s1 is basically greater than len 2 is greater than even len 1. Yeah, I want to keep the len 1 as smaller. So if length 1 is greater than length sentence 2, then I'll switch them. So I'll make them. I wish I could convert these to s1 and s2. Maybe I can, right? I think that will make our job easier. S1, S2. So if S1 is greater than S2, then I'll just say S1, S2 becomes S2, S1. That's perfect. Okay. Now let's start our logic. First thing is what I want to do is I think I'll just work with the left sentences. So L1 and L2, not L1 and R1, L1 and R1. No. Sorry, my bad. L1 and L2. So L1 pointing to sentence 1, L2 is pointing to sentence 2, and what I'm trying to see is L1's occurrences in L2. So while L1 is smaller than length S1 and L2 is smaller than len S2, and I want to check if the current words are equal. I don't care, like I can only keep moving forward if I see them equal. So S1 L1 is equals to S2 L2. Okay, if this is the case, I want to increment my L1 and I want to increment my L2. Okay, yeah, by 1. Now this will only break out if either we just ended up seeing the entire L1 first. We saw the entire sentence of S1 in the beginning of S2. Either that has happened, or we stopped seeing these words as equal. But you know what? That's not over, because let's say we only covered some part of S1 in the beginning of S2, but what I want to see is how about we still have a chance to see it might be in the back. So it might be the case where remaining portion is in the back of the S2. So that can be observed by the right pointers. So R1 and R2. So while the logic will be exactly same, it's just the pointers will be, if R1 is greater than 0, actually, yes, greater than or equal to 0, and R2 is I should have just written it. R2 is greater than or equals to 0. Since now it's we are bringing these pointers back. Okay, so R1, R2, and let's switch these as well. So what I'm trying to see is okay, R2. So this has seen if we could see some words or all of the words in the of sentence 1 in the beginning of sentence 2. Now we want to see if the remaining words, there might be remaining words that I can see in the end of the sentence. So what I'll do is R2, R1 and R2, I'm checking if that keeps happening. I'll keep bringing these 2 pointers are basically pointing to sentence 1 and sentence 2, and I'm trying to check if sentence 1's words from the back also seems equal to S2. So now what must have happened is I my basically what I was trying to check is L1 and R1, basically L1 and R1 for sentence 1. If they have crossed each other, that means we have seen all the words in S1 in S2, but that too in a particular order, either in the beginning or in the end, there might be some words in the middle, or the entire sentence is in the beginning, or the entire sentence in the end, right? So and there could be some words, we don't care about those. Now we can just return if L1 is greater than R1. I think that that is a proper check. And a really important thing that I forgot, I'm so stupid, is I assume that these S1 and S2, they're already, what they have given is already as an array, and of course it's a sentence, it's a string. So we need to basically to iterate, we have to split them with sentence by space actually. So I don't know, when you're moving these pointers right now, this is going to the next space. They should rather go to the next word. Okay, so I'm gonna do this thing. S1 will be basically S1 split, and we're gonna split them by space. Okay, this is S1 dot split. Yeah, I don't know, that was like really stupid of me. 2 and I think yes, now it should be all good. Let me run it on the examples. Okay, this passes. Now okay, 100%. I'm gonna go over this one more time. I know it was like a crazy problem. You split these two words, you basically swap them. If S1 was greater, then you simply want to check all the words occurrences, all the words of S1 in S2, but that too either in the beginning or in the end, either in the beginning or in the end, or basically like anywhere, but that should not happen that you could see some of the words of S1 like in the middle or in the end. So in that case, we have seen that example. I think example 3 we have seen. You know what? I think I'm done explaining this, because while explaining it, this problem is so crazy. Like time complexity is gonna be big of n plus m. Yeah, don't come after me if one of the stupidly complicated problem, I guess. Time complexity and space complexity, but I think it's a very useful scenario as well. Okay, so and space complexity, because we're splitting also occupies the same length. This is because we're doing double pass, and it will max can go up to the length of S1, S2, I think both. Okay, in this case, you can also consider this as like the maximum length of both of these. So, and then this is also going to be big of n and m. All right, this is happening like you're combining both of them, or it could be just max of m and n, I think, since these are like two different cases. Okay, I think this is it. Let's go to AlgoYogi and mark this solved. All right, see you guys later. Bye bye.